Hi everyone, welcome to my topic today. It's called The Hitchhiker's Guide to the Modular Galaxy. It doesn't really have anything to do with The Hitchhiker's Guide to the Galaxy, but it's a great movie and a great book, and I really recommend both. So let's get started with modules. But first things first, my name is Stanimira. I'm a software engineer at a company called Progress, and I work on this very cool open source project called NativeScript. I hope you attended Sebastian's talk yesterday. But if you didn't, NativeScript is a mobile framework. You're building native mobile apps for Android and iOS using things like Angular and JavaScript. And today I'm going to talk about my experience while working on the build system for NativeScript and how we were integrating with the Angular CLI and how I had to understand how the Angular packages are distributed, basically. I'm also a Google developer expert for Angular, and the best way to find me on the internet is with Twitter. But if you don't use that, I'm also on everywhere, Facebook, LinkedIn. Just type my really long name if you can remember that. But let's get started. So today we're going to talk about the Angular package format, basically how Angular libraries are distributed and why do we have the Angular package format and we don't have just a single bundle that is shipped. We're going to also take a look at the built Angular application and how the output files look like and how they actually work. And we're also going to take a look at the differential loading that was introduced in Angular v8 and the new code splitting pattern, or more specifically, what is the new value that you can provide to load children while loading a lazily loaded module in Angular. So let's get started. The Angular package format. The most simple thing, let's go to some Angular project, open the Angular package, open forms, and take a look around. And honestly, the first time I saw that, I had no idea what is going on. Like, we have bundles folder, we have ESM 2015, ESM 5, and a bunch of other things, and also typings, and it's kind of complicated. So this is my initial reaction, and it has been my reaction for a very long time. And it maybe still is, but it doesn't matter. So my story today is how I had to learn how the JavaScript module system work and why do we need all these files in an Angular package. And basically, if you're building Angular libraries and if you're using the Angular CLI, which is the recommended way, you're using the NgPackager package. And the NgPackager will take care of bundling your application and outputting the JavaScript files in a format that looks like we saw before. So it's not necessary, you don't have to do it yourself, of course, but it's good to know what you're shipping to the users. But in order to understand that, we'll go a little bit back in time. Do you know what happened in 1995? Like, probably many things, but come on, someone, anyone? Oh, no, it's not my birth year. Just It's actually the creation of JavaScript. All right, so in the beginning, JavaScript didn't really have a module system. Like, it wasn't created for whatever we are using it today, right? So it didn't really need a module system, probably. And this is what would have happened if we were running JavaScript code in the browser. So we have this simple JavaScript script. We have two variables, and if we embed that or include that in an index.html file, and we run that in the browser, these two variables are attached to the global object, and the global object is window. So with the lack of module systems, it means that we don't have really a very nice way to compose scripts or packages. We don't have any kind of isolation because all the variables are attached to the global scope. And we don't really have a nice way to reuse libraries and scripts and package them as packets and ship them around. But as time goes by, people started using JavaScript more and more for random reasons. I still don't get it. Just kidding. And they started creating some patterns for providing modularity. So let's just get that code and wrap it in a function. This means that the variables will be local. They will be scoped inside the function. They won't be attached to the global object unless we do that explicitly. And if we invoke the function and print the answer, it is 42, of course. And the reason, we don't know what is the reason for that. That's cool. And if we try to actually have a different variable and not attach that to the window object, it's pretty simple. We can create some variable, attach that to the window property, then we can accept the kind of global variable inside our function, and then we just need to invoke the function and we will have some kind of a scope. And of course, another thing we can do, we can immediately invoke that function. So this is the immediately invoked function evaluation pattern. We do have some kind of composability. We can ship around these functions and include them somewhere and invoke them when we need them. We do have some kind of isolation. We're leaking just one variable, usually on the window. We don't leak all our local variables. And we can kind of reuse packages as well, but it's not very convenient. And have you seen that? If you ever used the jQuery, you probably have seen that error. And there's there are many reasons why this can happen, but one very, very simple reason. Imagine that we have the jQuery library, which is essentially a script. And you included that in your index.html file as a script on the top, because you should do it on the top. Then you have your application scripts. Then at some point, for some reason, someone decides to swap your application script with the jQuery library. And if for some reason the first script tries to use the $, which is the global jQuery variable, it will get this error. $, is not defined. Why? Because the jQuery library should be the first one that's executed, and it should attach the $, to the window object. And the other reason why it's not very cool, there may be some malicious script or some random other package that can override the $. So it's not very extensible. It's not a real module system. We do have some nice things, but we don't really have any of these, like we have in other programming languages. So at some point of time, someone created Node and decided to bring JavaScript to the server, because everything is perfect with JavaScript, and we can use that on the server as well. But really, I really like Node.js. And the problem was that, okay, the other languages, like server-side languages and frameworks, have a very nice ecosystem and have pretty cool distributing system. How do we do that with JavaScript? We don't really even have a system to have modules there. Like, we can have ifs, but as you saw, it's not very extensible, it's not very convenient. So at some point of time, after Node was created, or before that, they created CommonJS, or the CJS standard. And this is not a standard that is part of the JavaScript or ECMAScript language. It's just a specification that Node implements, and it's basically baked into Node. And this is how it looks like. We have the require function, and require actually can be used to define your dependencies. And you get your dependency in a very predictable way. You don't have to order some scripts one after the other. You have actually a way to request whatever you need. And you have model exports. So this is the way to provide, to describe your public API. You have dependencies, you have your code, it is isolated, and you have exports. You have a public API. It's pretty cool. We can compose these, we can ship them to NPM, and people can grab these scripts, and they can actually use them as actual plugins. You have isolation, because people can only use and import the exported symbols instead of everything. We also have reusability. But as I said, CommonJS is baked into Node, and it doesn't really natively work in the browser. Also, it is synchronous, which is also not very convenient for the browser, because yeah, in Node, everything is on the file system. We can block the main thread for a while we're loading the script, but this is not very convenient for the browser, where we have to do network requests. And CommonJS is not statically analyzable, which doesn't work very good for tree shaking, and we're going to come back to tree shaking in a while, because that's very important for Angular, right? Bundle size, tree shaking. So CommonJS, not cool, not cool. It doesn't love tree shaking. Okay, how do we support browsers? One of the ways is to have bundlers, and these bundlers implement and understand the CommonJS standard and can bundle your code in such a way that the browser can also understand it. One very popular and my favorite example is Webpack. Back in the days, there was Browserify, which was probably the first popular bundler out there. And nowadays, we have Webpack, Parcel, and a few hundred other bundlers. And the other way is to use a module loader, such as System.js. What is the recommended way? Well, for me, it's bundlers, because you have your project, you run that through a bundler, you end up with just a few files, and you can load that. I mean, when talking about the browser, you can load that with just a few requests. And this is much faster than having thousands of HTTP requests and having to load 200 files at initial startup instead of loading one big bundle. There's a very interesting discussion about HTTP2 and server push, and if bundlers will make sense after a while with HTTP2. So we can follow that, but the kind of official statement is that for now, you should just bundle your code and have as less files initially at initial load as possible. Okay, then after CommonJS, people decided that, yeah, we do need asynchronous model requests in the browser. And they created another standard, AMD, or Asynchronous Model Definition. Its most popular loader is require.js, and obviously AMD is used in the browsers. Then someone said, yeah, okay, we have CommonJS, it's baked into Node. We also have AMD, is where it's used in the browser, but we want our libraries to be usable both for server-side and for the browser. So how do we combine these two standards? Any ideas? Yeah, we create, okay, this is AMD, it's not important, honestly. We create another standard, the Universal Model Definition. It's really cool. It works in Node, it works in the browsers. The only not cool thing is that that's how you write universal modules, you know, just a bunch of ifs. Like, you check, if you're in Node, if you are in CommonJS environment, then use the Node way of loading modules. If you're in AMD, if you have loaded AMD, then use define, because this is shipped with System.js or whatever, require.js, sorry. Then if you don't have anything of that, just use global variables. The dependencies should be there. And it looks terrible. It's pretty hard and error-prone to write that by yourself. Of course, there are tools that can bundle your code in a way that it looks like UMD. But people didn't really like that standard, and I'm not sure if anyone actually uses that nowadays, compared to, of course, what I'm going to show later. ECMAScript modules, finally, the best thing ever. Also known as ESModules or JS modules or ESM or 100 other things. It's the same thing. It's the actual standard for modules in JavaScript. It is standardized, it's part of ECMAScript, and most browsers nowadays implement it. From some recent statistics, more than 85% of the browser's users actually use browsers that support ECMAScript modules. And of course, when we have bundlers, we don't even have to care about the rest. We'll get to that point. Node also supports ECMAScript modules with some weird extensions, but that's not important for us. I hope you, yeah, never mind. Yeah, okay, just a quick note, the .mjs file extension. This is what people decided to use to distinguish between JS scripts and JavaScript modules. And MJS, it just really sounds like Michael Jackson or something like that. We'll get to that. So we have actually module system baked into the language, and it's implemented by almost everyone. This is how it looks like. And if you're Angular developers and use TypeScript, this should look very familiar. We have import and export keywords, and we have different ways to import dependencies and import specific symbols, like not the whole object, but specific symbols from whatever module we have. And we also have dynamic imports. Pretty cool thing. And the example that I'm going to show here is actually with lazily loaded modules and how you can define them with Angular 8. So we have load children, widely known, and we have a function which returns import. Import is the dynamic import. We provide the path to the module, and then after this returns a promise, after the promise is resolved, we just grab the exported about module from that module. And if you get confused here, yeah, so we have about.module. This is an actual JavaScript file, which can be an ESMoScript module. And we also have the about module class, which is an NgModule. So not very, not confusing at all to have NgModules and ESMoScript modules, but important thing here. This file, about module, and everything that's inside it, the components and all the services that should be used by it, will be bundled in a separate file. So the Angular build system will actually output a different file and split that part of the application in a different JavaScript file. So when we navigate to about, this JavaScript file will be loaded and will actually be executed. So the NgModules, and more specifically the lazily loaded NgModules, can be thought of these as the splitting points, splitting logical parts of your Angular application. So in some sense, they're also modules, not just abstract modules, but also when you bundle your application and you ship it, they're actually also modules. But they're different than the ECMAScript modules. Yeah, we import that, then we load it. Simple as that. The other thing that is pretty cool, and compared to CommonJS, the ECMAScript modules are statically analyzable, which means that we can get nice tree shaking. Let's see an example. Yeah, of course, smaller bundle size, but the example. We're importing RxJS and RxJS operators, and this is a CommonJS code. And then we're using two specific symbols and exported functions from these two libraries. And at this point, Webpack, which is the module bundler that is baked into the Angular CLI, will try to perform tree shaking. But if it sees this code, it can't really do anything. So we're importing two libraries. We don't know what we actually need from them. And this code is not statically analyzable, which means that by looking at it, we are not sure and can't tell right away without executing it, what do we need from these two libraries. And if we look at the ESModule example, we're importing especially just the two symbols that we need, fork join and map. And if you're not using RxJS or RxJS operators anywhere else in your application, all the other functions, all the other exported symbols from these two libraries can be tree shaken. They won't be included in the produced bundle. The only thing that will be included are fork join and map, and of course the private parts of the module that are needed for them. So this is very important, leads to smaller bundle sizes, and if you're using pretty large libraries, such as RxJS, which have plenty of functionality, and you need just a few specific operators or a few specific functions exported from them, everything else doesn't have to be in your bundle. And that's why the ECMAScript modules are pretty cool. Pretty cool, pretty cool. So, and then as part of the Angular package format, we have also flat ECMAScript modules. And I'm just going to show that because it's hard to actually explain it. I mean, it's not that hard, but I just want to brag about showing off code. Okay, we have this folder. We have a Angular application where in Node modules Angular forms. And as we saw, we have a bunch of folders. So I'm going to start from FESM 5. So FESM, I'm not sure if I'm saying that correct, but it stands for what? ECMAScript Module. And here we have just two files, forms.js and forms.js map. Okay, forms.js map is obviously some kind of source map that will help us debugging our code later. So we're going to concentrate on forms.js. And if we go to the top, we see that we have ECMAScript modules. This code, yeah, it was initially TypeScript. It was transpiled in a way that it is now an ECMAScript module. That's why we have the import keyword. So far, so good. We know that this is an ECMAScript module. And we have some variables lying around and some more variables. And we have something that used to be a TypeScript class, and now it's a function, of course. And if we keep going here, we can see a bunch of these. So we have another function. We have plenty of classes, actually. And some of these may seem familiar, like ngControl. This is an actual class exported from the Forms API. And if we go at the bottom of the file, we see a bunch of exports. So what is the deal here? We have all our code imported in this single file. All the dependencies that this file is importing are from external libraries. We don't have anything imported from the actual project, right? Which means that this is a flattened module. And if you're still not getting it, I'm going to show you the other folder, which is ESM5, or ECMAScript module, or non-flattened ECMAScript module. And here we have pretty much the same thing. If I go to the Forms API, forms.js file, it re-exports different classes and different public symbols from different files. And for example, if I look at the checkbox value accessor, this is the same code that we saw earlier in the flat module. The only difference is that it is in a separate file. So in ESM5, we have forms, index.js, and the source folder. And if you take a little deeper look at that, we can see that actually the whole JavaScript code is in this source folder. Pretty cool. So now we know what's the difference between FESM and ECMAScript and ESM. So with that, we have almost 4 of the folders done. And what is the difference between 2015 and 5? Well, 5 is for ECMAScript 5, or kind of the old standards of the ECMAScript language, and 2015 is for the new standard. And why do we need both? Well, depending on how you have configured your build, you may want to support older browsers or newer browsers. So that's why your build will pick up 5 or 2015, one of the two versions. What about bundles, though? Okay, in both bundles, we have .umd files. And if I open up one of them, this code was prettified by me before the talk. It doesn't look exactly like that. But we have an IFI. We can see that we are actually invoking that in the end. And we're checking, is this node environment? Do we have CommonJS here? So if we have exports or module exports, and if module is defined, this is a node environment. And that's why we're executing some logic, and we're defining the library in a way that is standardized by the CommonJS standard. If we're not in node environment, we check if the defined keyword is defined, which means that we can load the module as AMD or define the module as AMD. The defined keyword is provided by require.js or whatever implements AMD in this case. And it's pretty simple. We define the name of the of the module, and we define the dependencies. And then we provide the factory function that should be executed. And the factory function is actually the IFI that, or the function that wraps the module code. And of course, if you are not in Node and we don't have AMD, we check, we assume that everything is available as a global dependency. So we will attach all the exports to the global object as global.ng.forms, and all the dependencies should be present on the global object as well. This is the UMD, and the purpose of having and shipping UMD bundles as well is that this library would work in non-bundled. Okay, first it will work in Node, and second it will work in non-bundled situations. So actually, when we're building the library, how does our system, whatever build system, figures out which of all these files to use? Well, it's specified in the package.json. First, we have the main property. And if this is Node, this is the file that will be loaded when we type require Angular forms. And if you are not using a bundler, this is also the entry point. And if you are using a bundler, for example, building your application with the Angular CLI, which uses Webpack under the hood, this is the entry point for the bundler. So we have two different cases depending on how we are using the library. So far, so good. Also, one important note about FESM and ESM. I've tried bundling. Okay, I used Parcel to bundle the NativeScript packages, some of them, in a single file in a flattened ECMAScript module, and then run that through Webpack and compare that to using just a regular ECMAScript module. And honestly, there is no difference, at least from Webpack for until now on. So for me, the use of flat ECMAScript modules, but when using a modern bundler, is kind of questionable. But again, the ng packager does that for you, so you don't have to worry about it. All right, so that we now know how an Angular library looks like, we can actually take a look at an Angular application. I already built that application by using ngbuild. And in this folder, yeah, we have the app. We have a bunch of files, surprisingly. Let's take a look at a few of them. So this is the same app that I was showing in the example. So we have the about module, which is a lazily loaded module. And as you can see, it is in a different bundle. It's in a different JavaScript file. And we have two versions of it, ES 2015 and ES5. We also have the main file here. Again, two versions of it. And we have different polyfills for ES 2015 and ES5. And the rest of the things are Webpack specific things. For example, the vendor chunks will contain some packages from Node modules, some of the external libraries that we're using. And let's see what is actually loaded on the page when we load it. Okay, we have some things that look quite similar. First, we have runtime ES 2015, and then we have runtime ES5 again. So why do we need that? You can notice that ES 2015, all the scripts that are loaded and that are ES 2015 are loaded by using the type property, a script tag, which means that if the browser supports ECMAScript modules, it is going to load this script. If it doesn't support it, it is going to ignore it because it doesn't understand type module. And for other browsers, we have the no module property, which instructs the modern browsers that support modules not to fetch this script and not to load it. And it can be a little bit tricky here. We're actually asking the browser, do you support ECMAScript modules? If you do, then load this ES 2015 code that is actually not an ECMAScript module. But we still have a very obvious way to check if ECMAScript 2015 is supported. And what is exactly inside these modules? I mentioned that a few times. We are using Webpack to bundle the application. So we don't actually have ECMAScript modules inside these bundles. We have kind of a CommonJS implementation, and it is Webpack's way to package modules and distribute them. But which means that we don't care about other browsers or anything like that. And we also take all the benefits from tree shaking because we're transpiling the TypeScript to ES 2015. And the libraries are actually transpiled to ECMAScript modules, and when Webpack runs, it can use the static import and export symbols and do proper tree shaking of the libraries. So yeah, the final Angular application that we see here is not an ECMAScript module, but it's cool that the libraries shipped in the Angular ecosystem are distributed as ECMAScript modules so that we can take all the benefits from tree shaking. And if you want to learn more about the Angular package format, check out the design document. You can just Google it. It will probably show up, and you can also have access to the slides later. And if you want to learn how the ECMAScript modules are implemented and how they also compare how they are different from CommonJS, check out this amazing blog post article by Link Wark. It's really good, and it's very easy to follow and easy to understand. And thank you.